Okay, Ji. So this is the paper of 2012 November 22, and I am the one doing the paper, right? 000001 and 00001. Okay, Ajay ji, Ajo please. Kulmina, please read the question, yeah.
The drag force D on an object of cross-sectional area A, moving with a speed v through a fluid of density rho, is given by where C is D is equal to half C multiplied by rho A v square, where C is a constant. Show that C has no unit.
Sure that she has no unit. Okay, so whenever we do these type of question, we first have to ignore all those constants. Okay, so 1/2, we have to ignore that, and fine. And okay, so bro, what's the unit for the drag force? Force has a unit of kg. Come on, kg.
Meter per second square.
Very good. Okay, and what's the unit for the density? Kg per meter square.
Meter cube.
Very good, per cube. Okay, and what's the unit for the area?
Meter square.
Meter squared. And what's the unit for the velocity, please?
Meter per second.
Perfect, perfect. Okay. Now, ignore 1/2 first and make C the subject and then substitute. Okay. So D over rho A and V square, and we are showing that C has no units. Okay. So please make sure to make C the subject first and then substitute the unit. Otherwise, it will be difficult for you to solve or simplify, right? And the chances of the error will be higher. Okay. So kg meter second negative 2 divided by kg meter negative 3 and meter squared for the area and ms negative 1, and since it is squared, so you have to square it. Okay, now so kg and kgs goes off. Okay, I have just count all the meters. So I have 1 meter in the top. I have and one 2 negative second in the top. Okay, and I have a -3, positive 2 and positive 2. Okay, so meter -3. Okay, and meter is squared and meter is squared meter 4. So that basically gave me meter 1 only. Okay, wait, just come on. Shit, man. So meter cube and meter to the fourth power with the negative side. And if I count the seconds, so I have -2 in the denominator. Okay, so now meter on the top and um meter on the bottom, and second per second is squared on the top and per second is squared on the bottom. So that shows that C has no unit. No unit means just one, no unit. Okay, so C has no unit. Is that clear? Look, since since the question is a show that question, so it is actually of the 3 mark, but they are giving you 2 only because the third mark is for the answer, and since they have told you the answer, so that's why they are not giving you the answer mark, right? But you have to be very careful in the show that question. You have to show each and everything out, right? I showed this thing, I have to show the whole calculation and then reaches to this point. Okay, if you are very smart and you just do everything directly, then you won't get any of the mark. Okay, so be very careful. I can show you the okay, I can show you the examiner's report on that. We are doing 22. Okay, fine. Just for part A, the majority of the candidate obtain at least 1 mark. Look, majority of the candidate obtain at least 1 mark. The answer from some of the candidate were poorly presented and the working was difficult to follow. Okay, so please keep in mind you have to present it perfectly. Okay, guys, is that clear? Okay, let's move on. Gulmina, read Karlo, please.
A raindrop falls vertically from west. Assume that air resistance is negligible. On figure 1.1, sketch a graph to show the variation with time t of the velocity v of the raindrop for the first 1 second of the motion.
Okay, they're saying release from the rest, what does it mean? What will be the initial velocity?
Zero.
Zero. If they're saying negligible air resistance, what does this mean? What will be the acceleration then?
Zero.
अबे कद्दू कैसे?
पर constant होगा.
Yes, and that will be 9.81. Yes,
जी.
gravity acceleration equals to gravity, right? So you have to decode everything into physics, okay, from the English, okay. Now, if they're saying the acceleration is constant, तो आके वो क्या होने वाला है कि gradient आके वो constant होने वाला है इस ग्राफ का, ऐसे ही ना?
जी
Gradient should
sir.
be constant because speed time graph का gradient acceleration बताया करता है. Okay, fine. Now they're saying v of the first second, okay. अच्छा, what will be the final velocity then? क्या बता सकते हो आप? What will be the final velocity of the raindrop? Any idea? Come on, quick.
Sir, acceleration का वो होगा value.
9.81 with 9.8.
Hmm.
Very good, very good. Yes. क्योंकि they're asking for 1 second, you don't have any air resistance, so there will only be one force, okay, and you have the initial velocity 0. So at 1 second, if you apply the formula, a is equals to v minus u over t, and a is just 9.81 times it by 1 because they're talking about the 1 second. So v minus u is 0, okay, so 9.81. So at 1 second will be 8, 8.246, or 8.4, 8.8, 9.2, somewhere here, okay, like this. Is that clear? चलो,
जी sir.
परफेक्ट है, आगे आ जाओ, आगे रीड कर लो प्लीज.
Calculate the velocity of the raindrop after falling 1000 meters.
हम्म, कैसे निकालेंगे? Calculate the velocity of the raindrop after falling 1000 meter. Okay, if they're saying the air resistance is negligible, okay, so you have two options. Either you can use the kinematics, or you can use the law of conservation of energy, okay. So since after, okay, look, this is the case, this is the raindrop, okay, and it is falling 1000 meter, okay. So they have given you the height. You know the initial velocity as 0. You also know the acceleration as 9.81. Okay. So after, acha, we don't have any air resistance, so that is why we can either use kinematics or we can use the work energy power formula. Okay. We can do gravitational potential energy equals to kinetic energy, right? So we have the two options. Okay. Let's try. Okay. So kinematics लगा लें, so हमारे पास आ जाएगा 2as is equals to v square minus u square. So 2a 9.81, s is 1000, right? 1000, and u is 0, right? So आपके पास v आ जाएगा अंडर रूट करके. गुलमीन, आप समझ रहे हो ना?
जी sir.
सही है. एक तो ये तरीका है, दूसरा तरीका भी करके दिखा देता हूँ आप लोगों को. और यू कैन से pe is equals to ke, राइट? और आप कह सकते हो mgh is equals to हाफ एम वी स्क्वायर्ड. सो ये कैंसिल हो जाएगा. बेसिकली दोनों एक ही चीज़ है. 2 टाइम्स जी तुमने रखा 9.81, सो ये एच तुम रखोगे 1000 एंड तुम रूट कर दोगे, राइट? देख रहे हो, एक ही चीज़ हो रहा है. यस, हाउ मच?
140.
वही रूट भी किया.
जी sir.
140 तो बहुत ज़्यादा आना नहीं. 1000 140 कैसे आ सकता है? 10 के आसपास आना चाहिए.
Sir, 140.
है. अच्छा जी, मान लेते
It's
हैं आप.
140.
ओके ओके, मान लेते हैं. आई एम सॉरी. ये लो 140. मैं ज़रा चेक भी कर लेता हूँ सही जा रहे. वेरी गुड गाइस, वेरी गुड, बेहतरीन हो गया. परफेक्ट. ओके, लेट्स मूव ऑन. आगे रीड कर लो प्लीज.
In practice, air resistance on raindrops is not negligible because there is a drag force. This drag force is given by the expression in A, stating an equation relating the forces acting on the raindrop when it is falling at terminal velocity.
Terminal velocity meaning? Yes. that it is falling with a constant velocity. Constant velocity. Okay. And constant velocity means it is just on, it's just falling the falling with a equal force or balanced force, right? So अगर आपके पास रेन ड्रॉप है, so रेन ड्रॉप पे जो डाउनवर्ड फोर्स लग रही होगी, that will be its weight, and जो upward force लग रही होगी, that should be the drag force. Okay, that should be the drag force. Any other force in practice, the air resistance is not negligible. There is a drag force. Okay, fine. So we can say that weight should be equal to the drag force for it to be on the terminal velocity. Okay, चलिए आगे चलिए please.
The raindrop has mass 1.4 exponent negative 5 kg and cross-sectional area of 7.1 exponent negative 6 meters square. The density of the air is 1.2 kilogram per meter cube, and the initial velocity of the raindrop is 0. The value of c is 0.6. Show that the terminal velocity of the raindrop is about 7 meter per second.
Okay. अच्छा. mm, Drag force. Okay, fine. अच्छा. They're saying show that the terminal velocity. Okay, so we can use this formula. Weight is equals to drag force. Okay, and the mass is given, the area, everything is given, and the formula is also given. That is basically the drag force formula. Okay, so half. So we can say that weight should be equal to drag force, and drag force can be 1 over 2 c rho a v squared. Okay. So um अच्छा जी, ये हमारे पास आ गया, और क्या होगा? The mass is given, so mass is 1.4 exponent negative 5. Okay, and then weight is 9.81, and then just multiply it by 2 to get अच्छा जी, अब उसके बाद divide कर दो आप. So when you divide by the c, the value of c is given, yes, 0.6 into the density of the air is 1.2, times it by the initial velocity is 0. Okay, fine. We have the cross-sectional area as 7.1 exponent negative 6, and whole thing under root, right? Whole thing under root. Perfect. जरा सॉल्व कर दो.
Sir, 7.33.
अरे वेरी गुड हो गया. V equals to 7.33. Okay, show that वाला question था, so that's fine. Okay, सही है. Okay, please move on.
The raindrop reaches terminal velocity after falling approximately 10 meters. On figure 1.1, sketch the variation of with time t of velocity v for the raindrops. The sketch should include the first 5 seconds of the motion.
Mm-hmm. Terminal velocity after approximately 10 meters. Okay, on the sketch, the variation first 5 second. Okay, first 5 second. Fine. So we first have to work out at which velocity um reaches terminal velocity after approximately. Okay, so which means कि कैलकुलेट द, नहीं ये तो हम नहीं ले सकते. और क्या कर सकते हैं हम? 5 सेकंड तक के लिए बनाना है, एंड टर्मिनल वेलोसिटी हमें हमें हमारे पास आ रही है 7 तक, राइट? एंड टर्मिनल वेलोसिटी का हमें टाइम नहीं पता. ओके, वी डोंट नो द टाइम एट विच इट रीचेज its terminal velocity. So can we find out the total time? We have the distance, the time at which the acceleration become 0, and resultant force become equal. I can do, but that doesn't make sense. Drag force, नहीं यार, टाइम टाइम क्या होगा टाइम, क्योंकि हमें, चलो, if the time is not given then okay, if they're saying we have to sketch it, okay, sketch it, then it's a plus. Fine. So 6, 6.4, 6.8, and 7 would be somewhere here. Okay. So it should be a curved line. It should be a curved line like this. And then it will be the horizontal line like this. Okay. Fine. This is the only possibility, or this is the only thing that we can do, right? Okay, let me just see the examiner report and marking key first, because I'm not sure about this question. अच्छा जी, अच्छा जी, this is correct. Okay, they're saying for the equation, they're saying weight is equals to drag plus upthrust if you want to relate the upthrust. Okay, allow mg or weight for the and d for the expression for the drag. Okay, so if you don't allow the upthrust, then it will also be fine. Okay, they're saying the line from 0 0 correct curve to the horizontal line. Okay, we have to show the decreased sloping line, because or the we have to show the decrease in the gradient as the line progresses. Okay, and दूसरी चीज क्या है भाई, reaches 7 between, okay, fine, they're just saying कि you have to do it yourself, don't require any time. अच्छा जी, अगर हम इसकी examiner report check कर लें, so if we look at the examiner report, so examiner says that majority of the sketch were incorrect. Okay, the initial section that was meant to be a smooth curve with a gradually decreasing gradient was often poorly drawn or given as a straight line. Okay, so since there is the drag force present, so the acceleration will be decreasing, right? So you have to show the decreasing gradient, because the velocity time graphs gradient shows you the acceleration. Okay, so the horizontal section was frequently not drawn at this. Okay, the point between the curve and the horizontal section was drawn with an abrupt change of the gradient. A significant number of candidates try to draw the separate sketches in the space on the page 5 rather than follow the instruction to draw on the sketch. Okay, so these were the problem uh, that the student did in 2012. Okay, done. Ajavi. Let's move on to the second question. Nabil, can you please read the question?
State the Newton's second law.
हाँ जी, क्या कहते हो भाई न्यूटन सेकंड लॉ में?
Force
Yes.
is directly proportional to the rate of change of momentum.
Okay, very good. A better way is to say the resultant force. Okay, resultant force is directly proportional to the rate of change of momentum. Okay. Ajay, by the way, you are not allowed to use this kind of um like things in the exam, right? You have to write the proportional thing. Okay. Ajay, and let's see the marking key exam report first, because it is a definition. Look, there were many answers that are unacceptable, right? About the Newton's second law, they're saying there were many answers that are unacceptable at this level, such as the force is proportional to acceleration, or force is equal the mass and acceleration. Okay, you cannot write this. Okay, otherwise you won't get any marks for the Newton's law. Okay, so be very careful when they're talking about, or when they're asking about the laws definition, laws in definition, or any principle. You have to be very precise, very accurate, very clear. Okay, don't be direct, don't be general, otherwise you won't get mark. Okay, or you're not allowed to write the formula as well. Okay, like the way you do in your IGs. Okay, or O levels. Okay, fine, please move on, आगे read कर लो.
The ball of mass 65 grams hits a wall with velocity 5.2 ms minus 1 perpendicular to the wall. The ball rebounds perpendicularly from the wall with the speed of 3.7 ms minus 1. The contact time of the ball with the wall is 7.5 ms. Calculate the ball hitting the wall, the change of momentum.
The change in momentum. Okay. So if they're saying approaches, right, and they're saying leaving away, सही हो गया. भाई change in momentum का क्या formula? mv minus mu.
mu.
mu. Okay. So mass तो इन्होंने दे रखा है 65 ग्राम. ब्रो ग्राम को you have to convert it into kilogram. Okay, very careful. Okay, so 65 either divide by 1000 or do exponent negative 3. Okay, now for the velocity I'm taking mass common. Okay, for the velocity you have to do final minus initial, so final velocity is 3.7. Okay, do you consider or are you considering the direction? Yes, Abil.
Yes, sir.
So which direction? I'm taking this one positive and this one negative. Okay, so 3.7 with a positive sign, negative and negative 5.2. Okay, this is a very repeated error. अभी मैं examiner report दिखाता हूँ, उसके अंदर भी they mention this error. Okay, कि student didn't consider the direction. Okay, please calculate कर दो कितना आ रहा है. कैलकुलेटर लेके बैठो.
Sir, 0.58.
0.58. Okay, and okay, if somebody consider this direction as negative and this as a positive, then he or she has to put the negative sign, but the negative sign is not like required. If you ignore it, then you'll still get the mark. Let me see the marking key. Yep, they're giving you the mark and also the examiner report, because this is a very common mistake that majority of the candidate either subtract the two speed. Okay, you are not allowed to subtract it, you have to add the speed. Okay, either subtract the 2 speed or calculate the rate of change of momentum. Okay, rate of change of momentum is not required. Rate of change of momentum is a force which is required in the next part. Okay, the vector nature of the momentum was ignored by many candidates who did not include the change in the direction and failed to add the 2 speed. Okay, so this is the most common error, or this was the most common error at that time. And now, okay, please move on. The
The
magnitude.
magnitude of average force.
ओके. अच्छा जी, क्या फार्मूला भाई एवरेज फोर्स का?
Rate of change of momentum.
वेरी गुड, हो गया. So momentum is what we calculated, and the rate of change of momentum is the time is 7.5, 7.5, and the milliseconds. Exponent negative 3. Yes, कितना आ रहा है?
77.3.
77.3. Okay, perfect. So we just write 77 into SF. Okay. Now, please move on. आगे बढ़ ले भाई.
For the collision in B between the ball uh, and the wall, state how the following. सही तरह से दिख नहीं रहा सर, वो कटा हुआ है मेरी स्क्रीन पे.
Okay. State the following. State how the following Newton's third law. Fine, fine, fine. अब दिख रहा है? अच्छा. तो खैर, मतलब they are asking you to apply the Newton's third law in this case. So any idea? Since the ball is hitting the wall, so the ball will apply some amount of force on the wall, and the wall will gonna apply the same amount of force in the opposite direction, and that is the Newton's third law. Okay. So we can say that as the ball collide collide with the wall, as the ball collide with the wall, uh, the ball apply the ball applies the force on the wall the wall in reaction applies equal force in the opposite direction opposite direction on the ball. Okay, and this is the application of Newton's third law on the ball. Okay, so and since it is a theory question, so let's just okay, fine, let's move on, then hum check karenge. Okay, now they're saying apply the law of conservation of momentum. Okay, so the law of conservation of momentum says either the total momentum of the system should be conserved, or the change in momentum by one body should be equal to the change in momentum of the other body in the opposite direction. Okay, so we can say that the change in the momentum of the ball should be equal and opposite to the change in momentum momentum of the ball. Is that clear, guys? And Nabil, what do you say if they ask you about the elasticity of the collision? Any idea?
Elastic collision.
How? Wait, guess.
It
Uh,
rebounded.
No,
Kinetic
rebounds.
energy is conserved.
How? Like, how can you say kinetic energy is conserved? You did the calculation?
Uh, Actually,
Look, look,
wait,
look.
what's the question asking?
The
So,
question
so
was,
relative speed is equal to the relative speed of separation.
come on. Kai is very simple. Don't, okay, fine. The question is asking, state with a reason whether the collision is elastic or inelastic. Yes. Like, you cannot say, you don't need to prove it always as elastic, okay? It can be inelastic. But like you have to look at the scenario given. Yes. Any idea?
Inelastic because of different speeds.
Very good, very good. Because like the kinetic energy is related to the speed, and the speed of separation and speed of approach is also related to the speed. So you directly have to look at the speed of approach and the speed of separation. Okay. So you're saying the relative speed of approach and separation is different. Am I clear, Una? Is different. So um not conserved. So not conserved. Any problem, guys? Okay, let's move
No.
on. Acha ji. Acha, by the way, this portion, like this type of thing, like the nature of the solids. Basically, the third question is basically the part of. Acha, wait. We didn't see the examiner report for the part C because every writing question or every explanation question, always concerned with. I always consider the examiner report. Let's see what they are saying. Question three. Nothing. Give correct. What the hell? Okay, fine. Over here. The majority of the candidate, okay, the first C part one was where they asked for the Newton's third law application on the given scenario, right? So majority answers lacked the necessary precision. Okay, the question asked for the answer in terms of the collision between the ball and the wall. Often the answers given was generalized and therefore did not answer the question. Many candidates gave the action being equal to the reaction. This statement is not acceptable at this level. Okay, so you have to explain each and everything out. If you just write the force, or if you just explain the Newton's third law without relating with the scenario, or if you just state any general statement, then you won't get any mark. Okay, or maybe one. Okay, so the second part was where they ask you to apply the law of conservation of momentum. Okay, so the answers given were generally very poor, with a little or no reference being made to the momentum change or of the ball and the wall, or how they are related. Okay, the statement of the law of conservation of momentum did not on its own answer the question. Okay, so if you just write the law of conservation of momentum, that is in an isolated system, the total momentum before and after the collision is conserved or equal. This will not answer the question they are saying. Okay, so you have to relate, or you should be able to relate the momentum in the law of conservation of momentum in this type of scenarios, right? So like wherever the Newton's third law applies, law of conservation of momentum will also apply in those scenarios. Okay, so that's it. The correct answer with the reason was given by majority of the candidate, where they were asking for the elasticity. Okay, now, okay, let's move on to the third question. Acha, by the way, the third question, the arrangement of the material is not required in our syllabus anymore. Okay, so this part is, you can left this part. Okay, now Ajo bhai, please, Imad, please read the question here.
Figure 4.1 shows an arrangement for producing stationary waves in a tube that is closed at one end. Explain how waves from the loudspeaker produce stationary waves in the tube.
Uh-huh, what do you say?
So I don't know, they overlap.
Come on, what, in 3 mark you can't say that. Oh, look, uh,
They superimpose.
okay, good, but look, bro, you have to relate with a given scenario. Okay, so if they have the signal generator, they have the loudspeaker. So loudspeaker will generate the different signal or the different sound. So you have to adjust the frequency of the sound, and the sound will travel from the speaker, and it get reflected back from the wall, and it will overlap. Okay, and the incident and the reflected wave rays, since they are in the opposite direction, it should have the same frequency, same amplitude, and when they overlap, they form a series of nodes and antinodes. Okay, so this is a like complete answer. Okay, okay, Chani bhai, you can say that wave, come on, wave from the loudspeaker speaker um अच्छा जी move in the tube and reflected from the closed end closed end and overlap with incident wave. Okay, now um while while the two waves, like the incident and the reflected waves are the two waves are moving in the opposite direction, in the opposite in the in the opposite directions. Okay. अच्छा जी. और क्या लिख सकते हैं? I think that's it. Yep. Let's see the marking key and then examine the report, and then we'll move on. Um, Question 4. They're saying wave travel along the tube, okay, reflected at the close end, okay, end of the tube. Incident and reflected wave of the, or these two waves are in the opposite direction, okay, we wrote that down. Interfere or stationary wave formed if the tube length, okay, so they're mentioning the tube length as well, okay. We didn't mention that, so we may lose 1 mark, but let let's see what the examiner says. Okay, so majority of the candidate only score the first mark. Okay, so this is a very easy question, and like this is a repeated question. Okay, so you shouldn't lose this many mark in this type of question, these type of question. Okay, so majority of the candidate only score the first mark. The well prepared candidate went on to describe the two wave in the tube traveling in the opposite direction. Very few described the resulting stationary wave um begin due to interference of the two wave. Okay, I wrote that this point down. Interference or overlapping शायद maybe ये ना लिखा हो. चलो, I'm also adding this point. Okay. um, when they interfere interfere in the tube with the tube length equal to lambda by 4 or 3 lambda by 4 or 5 lambda by 4 and so on, right? So this will happen. Clear? Okay. Because it is like close at one end and open at the other end. So first possible harmonic is the quarter of the wave, right? So lambda by 4. Fine. Chalo, let's move on. Imad, let's move on.
One of the stationary waves that may be formed in the tube is represented in figure 4.2. Describe the motion of the air particles in tube at point P.
Okay. Point P. Okay, point P is the node, right?
Yes.
And at the node, since it has the zero amplitude mean no motion, nothing. Okay. So no motion. Okay. And at point S, yes. What do you say? Acha, by the way, please keep in mind this is a longitudinal wave, right? Because it is generated by the loudspeaker. Okay. So the particle will either go in this direction or go to that direction. Okay. It won't go up or down. Okay. Be very careful. Sahi na? So either you can say that maximum motion point or maximum vibration, right? Or you can say maximum amplitude, right? Maximum motion, right? But वो motion कैसा होना चाहिए? Maximum motion back and forth, back and forth. Okay.
So what if there was a point in the antinode?
There was a point. This is a point, huh? This is 90 node point.
So this is maximum displacement.
Yes. What? नहीं नहीं नहीं, क्वेश्चन दोबारा से पूछा आपने, सही नहीं पूछा क्वेश्चन.
So what if there was a point in antinode?
ओके. अबे कद्दू रिपीट करने का थोड़ी बोल रहा हूँ, मतलब look, this is the antinode. Okay, so if you place a point here or here or here, all shows the antinode. Okay, clear? So they are
Mm.
basically asking for the antinodes, right? Clear? Now, okay, आगे आ जाओ, आगे read कर लो.
The speed of sound in the tube is 330 meters per second and the frequency of the waves from the loudspeaker is 880 hertz. Calculate the length of the tube.
The length of the tube. Okay, so can you
This
find out? Uh-huh.
this length is equal to 3/4 lambda, right? It's
Very good, very good. Yes, because the second
because
harmonic
this I didn't memorize that. I just thought of the this is half a wavelength and the
and the quarter.
open end is quarter. Yeah.
Very good,
So
very good. Yeah, perfect, perfect. Okay, so basically, V equals to F lambda, and lambda is related by the wavelength in this way. Okay, so over here in the length we have 3/4 of the wave, or 3/4 of the wavelength is fitted. Okay, now we can find out the lambda and then we can plug in there and we'll find out the answer. So 330 divided by 880 equals to lambda, and then 3 times, like whatever the answer you are getting, just put it right here and divide that by 4 and equate it by, yes, how much?
0.28.
0.28. 0.28. The final answer?
Yeah.
0.28. Okay, perfect. Okay, okay, done. Fine. Let me see the marking key. 0.28. Okay, perfect. Okay, fine, your turn. You have to read this one.
Figure 5.1 shows a 12-volt power supply with a negligible internal resistance connected to a uniform metal wire AB. The wire has a length 1 meter and a resistance 10 ohm. Two resistors of resistance 4 ohm and 2 ohm are connected in series across the wire. Currents I1, I2, and I3 are shown uh, in the circuit are as shown in figure 5.1. Use Kirchhoff's first law to state the relationship between I1, I2, and I3. So,
Mm-hmm.
current entering a junction is equal to the current leaving a junction, right?
Very good, very good. Yes. So,
So I1 is
yes.
I2 minus I3.
Wow. Oh, Q. Why?
No, it no
Plus
because
I3.
it's
Bro, I1 is entering the junction, right? And I2 and I3 are leaving it, okay? So you have to add all the leaving current and you have to add all the entering current, getting? And you have to equate them.
oh yeah. Oh, okay, fine. So
Okay, so one.
calculate I1.
Okay. So I1 is basically the current in the battery. Okay. So to find the current in the battery, you have to find the total resistance of the whole circuit. And then you can find that out. Okay. So they're saying negligible internal resistance uniform wire AB has a length of 1 meter and a resistance of 10 ohm. Okay. So which means this whole thing has a 10 ohm resistor. Like you can assume this circuit as this way with a 10 ohm resistor and then a 2 resistor down there, a 2 resistor is down there. Okay, right, and this is 10 ohm, this is 4, this is 2, so you have to add 2 and 4 together, so it gives you 6, 1 over 10 plus 1 over 6. um okay, so by the way, can we do any other way? Can we have any other way? Oh yes. Oh no. We can either find out the current I2 and I3 and we can add them. This is the first possibility. The second possibility is just to find out the total voltage, the total, we have the total voltage, we can find out the total resistance and we can work out. Okay, so I'm doing that way. 1 over 10 plus 1 over 6, okay? And I'm just putting a -1 power, right? It will give me the total resistance. Just put
3.75.
3.75. Very good. Okay. 3.75 as a total resistance. Perfect. Now we have the total resistance. We know the voltage. V equals to IR laga do. V equals to IR. So the voltage is given as 12 divided by 3.75. Okay. Is equals to I1. Okay. How much?
3.2.
3.2. 3.2. Okay. 3.2222. Yep. Perfect. Okay. By the way, let's just see the examiner report because it's of 3 marks. So, question 4, question 5. Vast majority of the candidate was correct. There were many correct answer. Okay, nothing. Okay. So basically, the examiner mainly highlight the difficulties in the theory questions. Okay. Most of the candidate did like do good in the calculation question. Okay. Okay, fine. Let's move on. Irfan. Hmm. Okay.
Calculate the ratio x where x is power and metal wire divided by power and series resistors.
Perfect. Acha, what's the formula for power you use here? Either IV or V square R or I square R. Which one?
Will it make a difference? No, right?
Actually, no, but it will help you. It will ease your calculation. That's it.
I think IV then.
IV. Okay. So you don't know the current. So that's why you have to do an extra step to find out the current in the metal wire, right? Because we don't have like for if you're using any current formula, so the problem over here is you have to find out you should have the I2 and I3 in order to use any I formula. Getting? Okay.
Oh, okay.
Instead of that, just use V square over R, and I'll explain how or why. So
69.2.
अबे रुक तो 2 मिनट तो दे। हाँ, तुम तो बहुत रॉजर चल लोगे तुम। अच्छा जी, so V square over R1 and R2. Okay. So since we have the same voltages, okay, as it is, as they are, this is a parallel connection. So V1 and V2 to cancel हो जाएगा. So we'll be left with R2 divided by R1, and R2 is basically 10 and R1 is basically, sorry, no, 6. And like the power in the series circuit, and the series circuit has a resistance of 6 divided by 10. 0.6 आ रहा है भाई? Yes, Nabil?
Yeah.
Okay, let me also see. वो तुम्हारा क्या आ रहा था नबील? अच्छा, वेट 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 वेट।
सर वो दूसरा किया था मैंने,
नहीं
ए
नहीं नहीं
पार्ट
नहीं
किया
नहीं
था
नहीं।
उसका।
अच्छा, ए पार्ट क्या मतलब?
सर मतलब पावर एंड मेटल वायर ऐसा करके मैंने कोई कैलकुलेशन की थी।
नहीं मैंने एक चीज गलत की है। एक मिनट रुक। मुझे ऐसा लग रहा है। दे आर सेइंग, अच्छा अगर हम एक्स कह रहे हैं ना यार, पावर इन द होल मेटल वायर की अगर बात कर रहे हैं, मेटल वायर या ए से सी तक, कोई पॉइंट तो नहीं दिया हुआ इसने, नहीं दिया। नो। ओके, लेट मी सी द मार्किंग की, इज इट करेक्ट और इनकरेक्ट? Power, okay, we use this formula, okay, and they are getting 0.60, allow 3 over 5, okay, fine, correct, okay, perfect, clear हो गया? आ जाओ, let's move on, Irfan.
Calculate the potential difference between the points C and D, as shown in figure 5.1. The distance AC is 40 centimeter, and D is the point between two series resistors.
Okay, D is the point between two series resistors. Okay, this question is sort of difficult one for most of the candidate, I think. So, but yes, what you do?
Can you go back to the question?
Okay.
Just this is a sum of EMF or some is equal to sum of PD.
Um, Actually, no, it's very simple question, but you just need to do it. You just need to perform it correctly. Okay. So they are saying calculate the potential difference between the points C and D. Okay. So C is this point. So you have to find the potential at this point and potential at this point, and then when you subtract the two potentials, you'll get the potential difference. Okay. This is the concept. Clear? Yes, is that clear?
Yeah.
So, uh, if I try to find out the potential of C, V voltage at C, so that would be, okay, I know that the whole wire utilize 12 volt, okay, and the whole wire has a length of 1 meter, which is 100 centimeter, okay. So 100 centimeter utilize 12 volts, okay. So if 40 centimeters there, so how much potential drop there? Yes, so you just do cross multiplication, so 12 into 40, right, divided by 100, okay. So 48 and 4.8, 4.8, okay. 4.8. So this means the potential difference between AC is 48, which means this 4.8 lost here. Okay. So how much will be remaining? 12 minus 4.8 gives you 12 minus 4.8 gives me 7.2. So at C you'll receive 7.2. 7.2 at C. Okay. सही हो गया. This is the voltage or potential at point C. Clear? Guys, is that clear? उसको यहाँ पे लगा देते हैं. Paste. Okay. So um, PD at AC, PD at AC is 4.8. So voltage at C, voltage at C is equals to 7.2. Okay. Now, this is the first point. Now, you have to do the similar working for the resistors as well. इसको यहाँ पे लगा दो. Sorry, not, it should be C, not A. So, so basically the concept over here, if you find the potential at A, so you'll find 12. If you find the potential at C, you'll find 7.2, and if you find the potential at B, you'll find 0. Right? This is the concept. Now you have to do the similar working for D. So if I find out the potential difference, the the potential at D is basically equal to the resistor divided by total resistor, which is 6, total resistance, which is 6 times 12. Okay, so ones are, twos are, fours are. So yeah, so potential difference is 4. Okay, and now we have the potential at point C, we have the potential at point D. If we subtract, so we'll get the potential difference. Okay, so to find the potential difference, to find the potential difference, 7.2 minus 4 gives you how much? 5, 6, 7, 7, 3.2. 3.2. Guys, how many of you get it? Yes, please let me know.
सर वीडी में
Mm-hmm.
सर वीडी में तो क्या कहते हैं वो फोर, ये नहीं होता एक फॉर्मूला कि
4
रेजिस्टेंस
divided by
रेजिस्टर जो भी आपने इस्तेमाल करना है
okay,
ओवर
yes,
टोटल रेजिस्टेंस
बिल्कुल
मल्टीप्लाई
बिल्कुल,
बाय वी एन,
यस यस, बिल्कुल सही कह रहे हो आप.
तो आपने वो टू लिखा हुआ है
बट
तो
बट बट
फोर नहीं आएगा.
नहीं मेरा बच्चा, देखो ना, आप निकाल रहे हो डी की, राइट. डी मीन्स यू आर बेसिकली फाइंडिंग दिस रेजिस्टेंस, यू आर नॉट इंटरेस्टेड इन दिस ड्रॉप. ओके, क्लियर.
सर मगर
So
फॉर्मूला वी आउट इज इक्वल्स टू आर वन ओवर आर वन प्लस आर टू मल्टीप्लाई बाय वी एन,
सही है ना, बिल्कुल सही है. तो
तो
उसमें
वी
हम
आउट डी नहीं बनता इसके मुताबिक.
बच्चे, डी डी का मतलब क्या है? आप डी को इसके रिस्पेक्ट से निकाल रहे हो या डी को इसके रिस्पेक्ट से निकाल रहे हो? आप क्या कर रहे हो? यस.
डी को
देखो देखो देखो, मैं आपको बताता हूँ. देखो, look, if you are standing at this point, if you are standing at this point, there will be 12 volts, okay, because it is directly connected with the battery, right? क्या इसमें कोई प्रॉब्लम, एनी प्रॉब्लम इन दिस पॉइंट?
नो सर.
फाइन. Now if you work out, if you take this resistor, okay, if you are doing 4 divided by 6 into 12, आप ऐसे ही कह रहे हो.
यस सर.
So क्या हो जाएगा? 1 जा 2 जा 4 2 जा 8, right? Which mean out of 12 volt, 8 volt drops here. If it drops there, so this means it is consumed. Okay, so what will you get at D? Out of 12 volt, what will you get at D? Yes, Candy Bro, quick.
फोर.
4, very good, because 8 volt is consumed by the 4 ohm resistor, right? So there will be 4 left, and when you work out for this point, So 4 will be consumed by 2 and there will be 0 at this point. क्या ये बात क्लियर हुई?
Yes, sir.
परफेक्ट. अच्छा जी, इमान, आप कुछ कह रहे थे? इसकी मार्किंग की भी देख लेते हैं.
नहीं सर, सेम डाउट.
3.2. अच्छा, और इसकी एग्जामिनर रिपोर्ट भी देख लेते हैं. ये वाले दोनों पार्ट की एग्जामिनर रिपोर्ट देख लेते हैं. कि एग्जामिनर कौन सी गलती हाईलाइट कर रहा है. एग्जामिनर भी यही गलती हाईलाइट कर रहा होगा. ओके, सो दे सेइंग दिस पार्ट ऑफ द क्वेश्चन effectively differentiated the candidate. Okay, सही हो गया. So the weaker candidate treated the two section AC and AD as being in the parallel or only calculate the potential difference across AC and AD, right? जो कि आप लोग बात कर रहे हो. रस कैडी ब्रो ये कह रहे हो, इमाद ये कह रहे थे कि आप लोग जो है वो ए सी और ए डी को कैलकुलेट करो, बट दैट इज नॉट रिक्वायर्ड बिकॉज पोटेंशियल डिफरेंस मीन्स द पोटेंशियल लॉस्ट एट सम पॉइंट, राइट, या एट अक्रॉस सम रेजिस्टर. पोटेंशियल डिफरेंस का ये मतलब होता है, राइट. एंड वी आर इफ यू आर टॉकिंग अबाउट द potential at any specific point, so we calculate the remaining potential coming at that point. Okay, is that clear?
Yes,
So,
sir.
so the general representation was poor, and hence partial credit was given to award. Partial credit was difficult to award when the final answer was incorrect. Okay, fine. चलो भैया, क्लियर हो गया. आ जाओ भाई, लास्ट पार्ट है, आखिरी क्वेश्चन मेरे ख्याल से. वह एक क्वेश्चन और है. ओके, अब्दुल जिंदा हो? अब्दुल.
जी.
अरे हैवी भाई, रीड कर ले यार क्वेश्चन.
State Hooke's law.
तो क्या होता है भाई, कुछ याद है? बचपन में पढ़ा था.
Force is directly proportional to
फोर्स
spring
इज,
constant.
ओए इस एक्सटेंशन कीपिंग समथिंग कांस्टेंट, वो इसमें कांस्टेंट है. ओके, सो आप कह रहे हो कि फोर्स इज directly proportional. Okay, I'm not writing proportional. Force is directly proportional to the extension. सही है. um, till the limit of proportionality. Limit of proportionality. अच्छा, क्योंकि डेफिनेशन है, so I have to look at the examiner report as well. So
Till limit of proportionality is exceeded, right?
what? Yes, like till, like before the proportionality, it follows the Hooke's law, and after it won't. Okay.
Yeah, okay.
Okay, Janab. So yes. So this was okay. Fine. They're not writing anything now. Please move on. Yes,
Spring
Abdurrahman.
spring is attached to a support and hangs vertically, as shown in Figure 6.1. An object M of mass 0.41 kg is attached to the lower end of the spring. The spring extends until M is at rest at R.
Okay. Rest at R. Okay, fine. अच्छा जी, आगे आ जाओ.
Constant of the spring is 25 Newton per meter. Show that the extension of the spring is about 0.16 meters.
Perfect. हाँ जी, क्या कर सकते हैं? अच्छा, इन्होंने they have given you the mass. Okay. And the extension, वो extension आपको शो कर रहा है. Yes. What you do? फॉर्मूला लगा सकते हो. F is equals to kx, right?
You calculate weight, right?
Very good. Yes. So the mass is given. So 0.41 into 9.81 to get the weight, and divide by the spring constant, that is 25. So how much?
0.16.
Okay, 0.16. So x is 0.16. आ जाओ भाई, आगे आ जाओ अब्दुलरहमान.
The object M in figure 6.1 is pulled down a further 0.06 meters to S and then released for M just as it released. State the force acting on M.
Okay, so M is
Tension force. Yeah.
अच्छा, so M is basically the equilibrium position, right? ऐसे ही है ना?
हम्म
अगर आप देखो तो m इज द इक्विलिब्रियम पोजीशन, बिकॉज वो जो वहाँ पे उन्होंने कहा है कि एट r, r इज बेसिकली m, वो रेस्ट पे है। सही, आपने s से उसको रिलीज किया तो वापसी ऊपर गया। ओके, सो जब वो रेस्ट पे है, सो दिस मीन्स द डाउनवर्ड फोर्स दैट इज वेट should be equal to the upward force, that is some tension in the spring. Okay, so you can say that instead the force is acting. Okay, so the weight um and the tension, um the weight and the tension um in the spring, right? You can either say um or acting equally, yeah, equal in magnitude, but opposite in direction. Abdurrahman, can you tell me कि ये न्यूटन थर्ड लॉ लग रहा है या नहीं लग रहा? एनी आइडिया?
हाँ लग रहा है थर्ड लो।
लग रहा है? अबे नहीं लग रहा है bro. Newton's third law के लिए you should have two objects. Okay, this is only one object, and इस एक object के ही ऊपर उसका weight exert हो रहा है, और जो स्प्रिंग जो टेंशन लगा रही है वो भी इसी एक ऑब्जेक्ट पे एक्सपीरियंस हो रहा है, राइट? सो दैट इज व्हाई यू कैन नॉट से इट इज द न्यूटन्स थर्ड लॉ. ओके, for the Newton's third law you should have two different objects. Okay, so if you consider the spring and if you consider the mass separately, but you cannot consider that because the whole thing is connected. Okay, so yes, that's why. Okay, please move on.
The acceleration of m,
Calculate the acceleration of m. Okay, so m
m
is
is the
basically m, ये mass है. Okay, the object m, m is the object. Okay, so मुझे बताओ कि if it is at r, so it won't have any acceleration because at that point the weight and the tension are both equal and opposite, right? So resultant force will be zero and no acceleration. It will move with a constant speed. Okay, so we rather have to find out the acceleration at this point. Maybe. Yes. Okay. So for that, we can say that by force, the weight, we can do weight minus the tension is equals to ma, or I think so, yes. और कोई force लग रही है, spring constant we have and weight है, हाँ जी. हम्म, हम्म, और क्या कर सकते हैं? चलो ये लगा लेते हैं. सो फोर्स या वेट, अच्छा, पहले तो हमें पॉइंट द ऑब्जेक्ट m in the figure is pulled down further to s and then release for m just at release, just as release. okay, so s से अगर उसने रिलीज किया है, फाइन. अच्छा, फिर एक मिनट, इसकी एग्जामिनर रिपोर्ट देखते हैं पहले. ये पार्ट वन का जो ना फिर मसला बनेगा. पार्ट वन में एग्जामिनर रिपोर्ट कुछ और कहेगी. अच्छा जी. Part one, the majority. Okay, very few were able to name the two forces acting on the mass. Significant number of gave the tension force that act on the spring. There were other references to the air resistance, even though the mass was stationary. Okay, so the mass is stationary. Fine. Um, now the अच्छा, हम यही कर लेते हैं कि भाई हमारे पास जो है ना tension should be greater minus weight is equals to ma, right? And so tension in the spring is basically the Hooke's law, right? Or what the Hooke's law is. So हम इसको kx कह सकते हैं, right? Minus weight को हम कह सकते हैं mg, should be equal to ma, right? So k is basically 25, right? And you extend the spring, you extend it by 0.06. So just multiplying by that 0.06 minus mass आपको दे रखा है कितना था, पॉइंट फोर वन. सो 0.41. ओके, और आपके पास जो है 9.81, राइट? एंड होल थिंग डिवाइडेड बाय द मास विच इज अगेन 0.41. 0.41 इज इक्वल्स टू ए. निकाल दोगे भाई? कैलकुलेटर है, प्लीज कैलकुलेट कर लो. Yes, how much? Anybody, anybody?
6.15.
6.15 you're saying. अच्छा जी 6.15 चेक कर लेते हैं 6.15 3.6 3.6 or 3.7 wait 4.1 into 9.81 divided by 4.1 0.4 0.41 है 4.1 है 0.41 0.41 यस मैं भी 6.1 आ रहा है इसका मतलब है कि हमने कुछ गलत कर रखा होगा कोई कैल वो इक्वेशन गलत बनाई लेट्स सी 5.52 ओके अच्छा जी ये वाला पोर्शन तो हमने किया है अगर हम इसको देखें सो 25 into 0.06 ओके ये वाला पोर्शन गलत हो रहा है वेट हमने पुरानी वाली एक्सटेंशन नहीं वो की है एक मिनट इसके अंदर एक चीज़ और ऐड होनी चाहिए +0.16 नाउ अब सही हो रहा है सो बेसिकली आपके पास जो है ना जो पिछले वाली पार्ट की एक्सटेंशन थी द स्प्रिंग एक्सटेंड्स बाय 0.16 मीटर्स और हमने उसको इग्नोर कर दिया ओके हमने उस चीज़ को इग्नोर कर दिया था so that's why we are getting the incorrect answer so the total extension the total extension should be 0.06 plus 0.16 okay and then ये जब आप इसको करोगे so it will be 2.2 okay and then जब आप इसको सॉल्व करोगे you'll get 3.6 क्लियर हो गया अब जुमान क्लियर हो गया
जी जी।
मे बी वो शायद इसी मिस्टेक को यहाँ पे हाईलाइट भी कर रहे हो majority of the candidate considered only the force from the spring when calculating the acceleration of the mass. The effect of the weight of the mass was ignored, even though it had been used in B and is stated in C1. Calculate a candidate should be encouraged to consider the resultant force F when using F equals to ma. Okay, fine. चलो आगे आ जाओ आगे रीड करो प्लीज यस everyone. From the time the object M in the figure 6.1 is released to the time it first return to R. Okay. सो एस से जब वो वापसी आर पे जा रहा है तो आपको बस ये बताना है कि आपके पास जो है ना वो किस तरह से उसका चेंज उसके अंदर चेंज आ रहा है एनर्जी का चेंज आ रहा है राइट सो सो at S there will be maximum elastic potential energy right and moving to R it will have the maximum kinetic energy right so हम ये कह सकते हैं कि at R at R there will be there will be maximum kinetic energy there will be maximum kinetic energy sorry maximum गलत हो गया maximum elastic potential energy maximum elastic potential energy right not at R बल्कि at S ना क्योंकि initially उसने S से रिलीज किया ओके so initially at point S there will be maximum elastic potential energy and as it move move point to point R it convert into kinetic energy. Okay, is that clear, guys? It converted into kinetic energy. Fine. Like all of the thing convert into kinetic energy. The energy changes from the time the object M in the figure 6.1 is released to the time it first returned to R. Okay, रिलीज से वहां तक आ रहा है. ओके, अच्छा इसकी अगर एग्जाम का वो देख लें मार्किंग की और एग्जामिनर रिपोर्ट देख लें. सो हमारे पास है elastic potential energy is strain energy to kinetic energy. Okay, a strain reduce and velocity increase at और हाई. ओके फाइन, सही, हमने भी यही कहा है. बल्कि शायद वेट वेट वेट, लेट्स जस्ट लुक एट द एग्जामिनर रिपोर्ट. There were very few correct answers. Majority appear not to have read the question carefully. Very few differentiate between the elastic potential energy and the gravitational potential energy. Candidate gave the energy change from R to S instead of S to R. Okay, okay. So मैंने भी ये गलत लिखा है. सही है. Candidate gave the energy from R to S instead of, sorry D से मैंने सही लिखा है. So instead of S to R, basically आप you are releasing the object from S and the object reaches to the R, right? So this is what they are saying. Okay, others consider the mass to be stationary when it returned to R. It's not possible. It will reach the maximum speed, but maximum constant speed. Okay, many of the answers suggested that there was only an interchange between the kinetic energy and the gravitational potential energy. The description was random. Given explanation as asked for this question. Okay, fine. So I think this is correct. Converted to kinetic energy. I can add one point as the speed increases. सही हो गया. चलो भाई, लास्ट क्वेश्चन. लास्ट क्वेश्चन, वेरी इजी क्वेश्चन. ओके, गुलमीना आपने कर रखा है, जरा गुलमीना सॉल्व करवा दोगे प्लीज. गुलमीना भी आप लोग ने पढ़ा है, आपके लिए आसान हो गया क्वेश्चन.
A nuclear reaction between two helium nuclei produces a second isotope of helium, two protons and 13.8 of energy. The reaction is represented by the following equation. Complete the nuclear equation.
इसको क्या पढ़ते हैं?
Mega
Electron volts. Okay,
electron volt.
and you should know the conversion. One mega electron volt is equal to 1.6 exponent negative 13. And if they just say 1 electron volt, so it should be equal to 1.6 exponent negative 19 joules basically. Okay, so electron volt is a smaller or baby unit for the joules. Okay, joules, we use the joules for bigger thing and use a electron volt for the smaller thing like the electron or something like that. Okay, yes. Complete the nuclear equation. Yes, Gulmina, what do you say? Any idea? It will convert into acha, a proton will have one proton and one nucleon. Okay, and two of the protons are being released. So the helium would be 4 and 2, right? Is it conserved? 2 and 2, 4 and 3. Yes. Okay. Gulmina, you get it?
जी सर, समझ आ गया.
Fine. आगे आ जाओ, आगे read कर लो.
By reference to this equation, to this reaction, explain the meaning of that term isotope.
Isotope. Yes. What do you say?
It's when the same element has, the same equal number of protons, like in different number of neutrons.
Okay, but bro, they're saying by reference to this reaction. You didn't give the reference, okay? So you have to say,
So
हाँ बोलो बोलो.
they have the same number of protons, which is 2.
Okay, very good.
Lekin only 2 of the helium atoms have one less neutron.
Good. Okay, so we can say that the or both the helium or both, come on, both the helium atom has same proton of 2. सही है, but helium to the left, helium to the left or helium the product, helium to the left has one more one more neutron. Okay, neutron. So if they ask you the definition, and they also ask you to relate it with a case, so you also have to relate it with a case. Okay, otherwise maybe you lose the mark. Let me see, let me show you. They're saying nuclei, both the nuclei have two protons. Okay, okay. अच्छा इसकी examiner report भी check कर लेते हैं. इसकी examiner report says this part was generally answered correctly. Many minority made error by ignoring the factor of two. अच्छा sorry equation वाला है. Okay, part B was the definition one. There were only few candidates who described the meaning of the isotope with reference to the nuclei. Okay, even अच्छा you have to mention the nuclei term. Okay, or nucleus. Atom of the same element ना बोलो तो बेहतर है, right? Atom of the same nuclei कह दो. Okay. So even fewer references to the nuclear equation given in the question. Many majority who scored any mark gained just 1 mark for the reference to the atom having the same number of proton but different number of neutrons. Okay. So what if you just wrote the definition, you only get 1 mark. Okay. Yes, आगे आ जाइए please.
State the quantities are conserved in this nuclear reaction.
Yes. Any idea?
Protons same day.
Proton and neutrons, right? Any other?
Sir, is charge considered?
Um, Actually always, but over here we don't have any charges. नहीं, by the way charges they didn't show the charges, so आप नहीं कोड कर सकते हो. And neutron number, what about the momentum? Come on. So proton and the neutron number, right? We say the momentum, right? We say the momentum. Okay.
Sir, sorry, momentum का मतलब क्या है इसमें?
Bro, when like these are the two helium atoms, so these two helium atom approaches toward each other, right? So whatever you find out the initial momentum, and after the reaction, the helium atom and the proton will move in the opposite direction to conserve the momentum, right? Because if you're reacting the two particles, so they have to collide, okay? And if there is a collision, then there will always be a momentum, and momentum should be conserved, okay? Clear, ना?
ठीक है sir.
Perfect. Okay, Janab. So momentum should be conserved, right? And the third thing is mass and the energy. Okay. Look, so over here, initially we have two helium atom, they have their masses, okay? But finally, there is some energy giving off, right? In the form of maybe electromagnetic radiation, gamma radiation, right? So finally, the mass of the product will be lesser than the mass of the reactant, okay? So and the difference in mass is basically over here, what converted into energy, right? So we say the mass energy will always be conserved, okay? So mass energy should be conserved, right? And if somebody asks you the explanation, then you say, okay, the mass of the reactant is greater than the mass of the product, and the difference in the mass is basically converted into kinetic energy or some other form, right? Like if the reactant has a mass of let's say 10 kg, and out of that 10 kg, only 8 kg convert into the product, okay, and the remaining 2 kg convert into the energy. So the product have some kinetic energy, so they start moving or it convert into some other form of energy like light or sound or something, right? So okay, let's move on. Yes, Gulmina.
Radiation is produced in this nuclear reaction. State a possible type of radiation that may be produced.
Okay, so we have the energy. So is energy related to gamma radiation? Okay, so gamma gamma radiation. Okay, आगे आ जाओ.
Why the energy of this radiation is less than the 13.8 mega electrons. Sorry, आपने इसका क्या कहा था?
Mega electron volt.
Mega electron volts given in the equation.
Okay, because the product will also have some kinetic energy as well, right? Like the product will be, the reactants will be moving, the product will also be moving, right? And they also emit the gamma radiation while moving, right? So they have the kinetic energy and they have the electromagnetic energy. Okay, so electromagnetic energy is over here, and the kinetic energy, you can write kinetic energy right here. So product product will have kinetic energy as well. Okay, आगे आ जाओ. Let's move on to the last part.
Calculate the minimum number of these reactions needed per second to produce a power of 60 watts.
Okay, minimum number of these reaction. Okay, so they have given you the power. They also mentioned the energy. So just find out the energy produced per reaction. Okay, needed per second to produce power. Okay, so if we convert this, so 13.6, 13.8 exponent into 1.6 exponent negative 13. So this will convert the electron volt into joules. So this is the energy in one reaction. Okay, निकाल दो भाई कितना आ रहा है. एंड हम क्रॉस मल्टीप्लाई भी कर सकते हैं. हम ये कह सकते हैं कि भाई if one reaction produces if one reaction produces this much amount of energy, 13.8 into 1.6, बार बार लिखने की क्या जरूरत है, कॉपी पेस्ट कर देते हैं. सही है. If one reaction produces this much energy, then if we want to make, अच्छा, they're saying 60 watt per second. So per second mean this 60 watt can be converted into 60 joules as well, right? Because power is equals to energy upon time, na? And time is just 1 second. So if you multiply the power by one, you'll get the 60 as your energy as well, right? So if you required 60 joules of energy, right? So how many number of reactions you want? Okay. So you just need to do the cross multiplication. Okay. So just do 60 divided by the whole thing. 60 divided by the whole thing. Yes, how much?
2.7 2.72 exponent 13.
Okay. 2.7 exponent 13. Okay, fine. And 2.7 exponent 13. Okay, is that clear? बच्चों सबको समझ में आ गया? इमाद, कैंडी ब्रो? Yes.
So how did you find the 13.8 times the energy?
Like this is the energy. This is the energy given 13.8 in the question, and to convert it into joules, I just multiplied by 1.6 exponent negative 13. Clear? Because this is the conversion factor that I told you. Okay. Yes. Is that clear, Imad?
Yes.
Perfect. अच्छा जी. So this is by the way November 2022, okay, 2012, जो कि हमने कर लिया. होमवर्क सुन लो, उसके बाद क्लास एंड करते हैं, राइट? चार चीजें हम लोगों ने करनी है, चार पेपर. मई जून, जून का आपने पेपर करना है 2012, 2012, 21 एंड 23. ओके, एंड नवंबर का पेपर आपने करना है 2012, 21 एंड 23. ओके, ये दो पेपर होमवर्क हैं, ये चार पेपर होमवर्क हैं, राइट? बिफोर द नेक्स्ट वीक मुझे ये चारों पेपर चाहिए, राइट? बिफोर द नेक्स्ट सैटरडे आई वांट ऑल ऑफ दीज पेपर डन, और मुझे इसका पीडीएफ चाहिए, राइट? अगर पीडीएफ नहीं मिलेगा मैं क्लास में नहीं बैठने दूंगा नेक्स्ट क्लास में. ओके, तो इसलिए प्लीज जो भी बच्चा आ रहा है ये चारों पेपर मुझे करके देना है, ओके, क्योंकि अब तुम लोग के मे बी मॉक चल रहे होंगे, सो यू हैव टू डू प्रैक्टिस, ओके। और प्रैक्टिस अब 5 पेपर से होगी, सो ये चारों पेपर तुम लोग ने करना है। थोड़ा सा टाइम निकालो, उसकी पीडीएफ बनाओ, पीडीएफ बना के भेज दो, ओके। चाहे तुम कहीं पे भी करो, दैट डजेंट मैटर, मुझे उससे कोई कंसर्न नहीं है, बट कॉपी पेंसिल पे करो, करके भेजोगे, राइट। क्योंकि मैंने तुम्हारी वर्किंग देखी है कि तुम किस तरह से वर्क, कि तुम किस तरह से ना पेपर सॉल्व करो, चीज़ अप्रोच करो, राइट। तो ये 4 पेपर है नेक्स्ट क्लास के होमवर्क, यानी सैटरडे से पहले पहले के होमवर्क। एंड इन चारों पेपर की 21 और 20 जून 21 23 की वीडियो अपलोडेड है। अगर तुम्हें कोई भी मसला है तुम उसको जाके देख सकते हो, ओके। नवंबर 22 की वीडियो इंशाल्लाह अपलोड हो जाएगी एज सुन एज पॉसिबल, 23 की अपलोडेड है, ओके। सो तुम्हें कोई भी मसला है तो एंड ऑन द स्पॉट भी उसको सही कर सकते हो, ओके। सो तुम्हारे पास सारी चीज़ें मौजूद है, यू जस्ट नीड टू कंज्यूम इट, ओके। मैंने अपनी ही वीडियो बना के डाली हुई है, मैंने अपने प्लेलिस्ट का लिंक भी तुम्हारे साथ शेयर कर रखा है, ओके। सो तुम 23 की तो प्लेलिस्ट का लिंक शेयर किया, मैं 21 की भी मैं शेयर कर दूंगा, ओके। सो बस तुम्हें सिर्फ और सिर्फ इसको एग्जीक्यूट करना है, दैट्स इट। अभी सिर्फ एग्जीक्यूशन टाइम है, सोचोगे या देर लगाओगे देन तुम मिस कर दोगे, ओके। सो बी वेरी केयरफुल, और जो है ना अभी से फौरन इसके काम शुरू कर दो, ओके। क्लियर हो गया? चलिए जनाब, चलिए बस अब आज की क्लास एंड करते हैं। ओके गाइस, टेक केयर बच्चों, अल्लाह हाफिज़।
सर ये सॉल्व पेपर भेज सकते हैं
बिल्कुल
प्लीज?
भेज दूंगा, बिल्कुल भेज दूंगा भाई,
ओके,
सारे
थैंक
सॉल्यूशन
यू।
भेज दूंगा, चलिए। ओके, अल्लाह हाफिज़, अल्लाह हाफिज़ गाइस।